Hello everyone, I'm Chef Tom and welcome back to the 65816 ATX project, or as I call it, Project Neon Sunrise. Uh, this week, I admit, I have made a huge mistake. So today's goals will be to explain why I'm not soldering the V3 prototype board, and use the time this week instead to design a soft reset circuit, soft power on circuit, without using a supervisor IC. And then build that into the KiCad project for the 3.1 board that you've seen me build, so I can send that one off to get built, and then we'll build that one. So I've got the 3.0 board here, and I've really been debating whether or not I want to build this board right now. Mostly because there are three distinct problems with this board. First is that the ground pin for the 6522 just isn't connected to anything right now. That's a super easy fix with a bodge wire to another ground pin though. Second is the fact that I'm missing the logic for the 6551 to be able to trigger an interrupt. I forgot that it's open collector, while the 6522 is not and drives the line high until it needs to drop it low, which means I need an AND gate and a pull-up resistor. And third, I have power and ground reversed on the 6551, so to fix that is going to be a lot more work than just running a bodge wire. I debated building it without using the 6551, but then I basically just have the version 2 board all over again. I do have the 6551 still on the breadboard for the version 2, and I might be able to move that over, but again, I don't have the decoding circuitry for it to trigger an interrupt, even if I were to do that. To be honest, I really just wanted to sit down and solder and kind of find a zen place for a little while, but I can pretty safely assume these holes are the wrong size for the standoffs, so I'll need to edit that footprint for the 3.1 board anyway. This one over here that I put in manually is the right size for an ATX mounting point, and it's definitely bigger than these other ones, so yeah, they're probably too small. So I'm not sure it's worth building this board, and even if I did, it is definitely not worth putting any ZIF sockets in here because they're expensive pieces for a board that is really only going to be used for a very short time, and desoldering them does not sound like fun. So I'm pretty sure it's just not worth it to build this board right now. But that doesn't mean I'm not going to do any work. I can definitely take a little time and build the RC circuit for the automatic soft reset. So I think I'll work on that today instead. If it does work, it's something we can build into the 3.1 board before we send it off to get made. And, I'm going to have to think about this for a minute, but I'm sure we can come up with something. So I've been thinking about the power on reset circuit for the 65816 ATX project. And I'd like to keep it super simple, in the vein of the C64-128 era. So I want to stay away from something like a supervisor IC or anything super complicated like that. So I'm going to start with the 555 timer. I know that's going to help with debouncing the reset button. Then I just need a way to trigger it after a slight delay after power up. So let's just start by building our monostable 555 circuit. Let's just ignore the fact I'm using random colors for our wires just so I can get a prototype built real quick. For the debounce, I'm using a 0.47 microfarad capacitor and a 1 megohm resistor, which will give us just under half a second of debounce time on the trigger. Assuming I've done this right and I haven't done something stupid like put my LED in backwards, this should just work. Let's try that again. There we go. But this circuit doesn't really help me because reset resets when it pulls low, not when it pulls high. So we're going to need to run this through an inverter. But this still doesn't solve the problem of power up, because when I connect power initially, nothing happens. I need it to wait, then pull the line low, then release it. Since I already have one in my design, and I'm not using all the gates on it, I'm going to grab a 74HC14 Schmidt triggered inverter gate and put it on the breadboard. And since we're using it in our 555 circuit, let's replicate that with the 1 meg ohm resistor and the 0.47 microfarad capacitor for our RC circuit. I had the circuit backwards in my head, and I thought I needed to feed the RC circuit into the inverter into the switch. But it actually turns out I just need the RC circuit on the switch, and then the inverter just to flip the signal that comes out the other side. So I'm going to go to KiCad with that, but I do want to have a longer wait on startup. So we're going to go to a full 1 microfarad capacitor to get a full second on startup, and then we'll have a half second anytime we hit the reset switch after that. So this is our version 3.1 board we've worked on previously. Big thing here, 6551 is now connected to ground and power properly. The rest of that circuit remains the same. The big thing we want to change here is making our reset switch. So I'm going to pull this out over here so we can work on it. So our reset, we need to add 555 timer. All right, so we'll move you over here. Flip it on its y-axis so that pin 2 is on this side, pin 3 is on that side. Our startup RC circuit, we're going to come down here. And because we want this to have a fairly long wait to make sure everything gets stabilized, we'll do 1 microfarad. And we're going to turn this into a 1 meg ohm resistor. So that will give us a full second before the system tries to do anything. It will hold the line high. When it drops low, that'll set the trigger on the 555. Now we basically need exactly this. For this, we decided we need this to be real short. Not real short, 0.47 microfarad. So we get a half second every time we trigger this. Inverter Schmidt trigger. All right. All right. Anyway. Now, one thing I noticed we didn't have before was we don't have a power or a status LED or anything. So I'm going to add 3-pole tool ACA LED here. Now the point of this is this will give us our power status and our reset status in one LED. Since I have red-green LEDs, what it'll be green when it's powered on, and with the red turned on next to it, it will look amber. So we'll get green, then we'll get amber on reset, and then the reset will turn off. So what we've got is our switch, and pins 1 and 4 are electrically connected, so I don't have to make this connection here. But also means it passes through this into this. This will pull it low while the capacitor is charging. Just a quick note, I realized the 7432 OR gate was not going to help me with my interrupt logic when I need it to be an AND gate, which I happen to have a spare 4 input AND gate over here, so by tying 2 of them high, it becomes a 2 input AND gate. And then that OR gate goes over there. So I have a chip that I'm only using 1 gate on, but I don't have another way to use it. We can see our vertical resistors mounted here, because I didn't want to change the footprint of the whole board. You can see everything's labeled. I added the green, amber, red LED here. We have our green, amber, red. Made a little exclusion zone for the handle. We can see all of our capacitors are numbered and valued, and bus down here complete with our unused pins. We could bodge something into these 3. And from the 3.0 board, I reorganized this so that all of the VIA pins are over here, which going forward probably won't be accessible. Because after this version, once we have this version working and I have the software working for the serial port, I'd like to migrate to the 65816 board finally, though probably not in the ATX form factor. And assuming our reset circuit works here, which it should, we saw it on the breadboard, and everything else is wired up right and everything else is working, and we can get the serial software working, then the next step would be to move this to the 65816 design, where I won't have access to VIA 0. VIA 0 will be dedicated to just the LCD and some other system peripherals that can use up just the remaining pins on via port A. And we'll add via 1 at another address location, and we'll make via 1 accessible to the users, while via 0 will be locked down internally. So now that we have the power on reset circuit built and designed into KiCad and into our board design, we're going to send the board off to get built, and then we should be able to test it from there. Our next software goal is to work on the serial interface and monitor so that I can write code back and send it across. And the next hardware project is to design a real-time clock circuit. I've got the chip, I have the data sheets, I have no idea what I'm doing with it, but again, that'll be that breadboard connection header. I'll be able to put the real-time clock out on the breadboard. I'm planning on tying it into VIA 0. That'll be one of the internal things in VIA 0 that it's locked down to. Hopefully that will work. If not, I'll come up with another way to deal with it. There's the potential to add FIFO memory or something, I don't know. But that's on the agenda for hardware projects as well. So, if you have any questions, of course, put them in the comments. I try to respond to everything. If you like what I'm doing here, like, subscribe, comment, thumbs up, all that fun stuff that you do to all your other YouTube friends. It lets me know that there is interest in this project. I'm going to keep doing it no matter what, but if there's more interest and more community around it, then I can see the possibility of doing more with it. And your support just kind of helps keep me going. I really appreciate it. And until next time, I'll see you later.